Okay, this is the Unit 2 Lessons 1 through 3 practice quiz. First question, we've got x to the negative fourth times x to the negative fourth times x to the positive fourth, and we need to simplify the expression. So this problem uses the first property of the exponent properties poster, where you just need to add the exponents. And so we're going to add negative 4 and positive 4, and when we do that we get negative 4. And then the sixth property from the exponent properties poster says that you can't leave a negative exponent in your answer. So we need to put this in the denominator, and it's going to be 1 over x to the fourth power as your final answer. For question 2, you've got negative 2 times b to the negative 2 power times c to the third power, and that whole thing is raised to the third power. So the first thing I'm going to do is use property 3 off the exponent properties poster and distribute this third power to each of the terms inside the parentheses. So we have negative 2 to the third, b to the negative 2 to the third power, and c to the third power. Negative 2 to the third power is 8, and then property 3 of the exponent properties poster tells us that when we have a power to a power, we multiply the two powers together, so this becomes b to this negative 6 and c to the ninth. And because the b is a negative exponent, we're going to put it in the denominator as a positive exponent, so your final answer would be negative 8 c to the ninth over b to the positive 6. For question 3, we're basically combining the concepts of problems 1 and 2. So what I did is I took the numbers off of the terms 3 times 5 and did that separately. And then I put all the x's together in a set of parentheses and all the y's together in a set of parentheses. So we have x to the negative 2 times x divided by x to the negative third to the fourth, which is right here. And then I took all the y's again. For simplifying x to the negative 2 times x, we're just adding the exponents. That gives us x to the negative 1. X to the negative third to the fourth power, we are multiplying exponents, so we have negative 3 times 4 gives me negative 12. For the y's, we have y to the third, y to the negative 8th. You're going to add them and you get negative 5. And then the last step, property 2, says that you subtract these exponents, so we'd have negative 1 minus negative 12, and that gives us 11. So we have 11 on the top. And if I do negative 5 minus negative 2, I would have gotten negative 3, and then I put the negative 3 y to the negative third power in the denominator as a positive power, y to the positive third. So your final answer is 15 x to the 11th over y to the third. For question 4, we've got one expression times another. We need to distribute to solve this problem. So we're going to distribute the w to each of these three terms and the 2t to each of these three terms. When you distribute the w, you get this top row. When you distribute the 2t, you get this bottom row. You'll notice that the w squared t's and the wt squareds both cancel out. So your final answer is just w to the third power plus 8t to the third power. For question 5, it says the area of the base of a rectangular box measures 2x squared plus 4x minus 3 square units. The height of the box is x. Find a polynomial expression for the volume. Because we're looking at a box here, we need to picture a box. Essentially, for a box, you would have the length times the width times the height to get the volume. But another way of representing the volume of a box is doing the area of the base, which for us is a rectangle, so it's the length times the width, but we have that expression already, and we're multiplying that by the height. So area of the base is the first expression, and the height was x, which they gave us. We're just distributing the x times each of these three terms, and we get 2x to the third plus 4x squared minus 3x, and that is our volume of this rectangular box. For question 6, we have a polynomial, 3 terms, divided by a monomial, 1 term. So I just rewrote it in the division form with a fraction. And then what I did was I found the greatest common factor of the numerator, and I figured out that it was negative 6x squared y, which obviously is the same as the denominator, and so they cancel out. And your final answer is 5x minus 2y plus 3. For question 7, there's a little trick here. You have a polynomial of 4 terms times a binomial, and the binomial is raised to the negative 1 power. And so initially it looks like a multiplication problem, but because this is a negative exponent, you need to put the expression in the denominator to make it a positive exponent. And when you do that, you will realize that this is a division problem. So I did synthetic division to simplify this. The number 2, the number that goes in the box is negative 2, because negative 2 plus 2 would have given me 0. And then the top row again is your coefficients off the numerator. So we had 1, negative 3, 5, and negative 6. But notice that we had 4th power, 3rd power, 1st power, 0 power, and there was no 2nd power. So I have a 0 as a placeholder for my 2nd power. That's what this little phrase says right here. So again, we bring the first number down, we multiply anything in this bottom row below the line times the number in the box, and we put our answer in the second row. We're adding, so negative 3 plus negative 2 is negative 5. Negative 5 times negative 2 is 10. 0 plus 10 is 10. 10 times negative 2 is negative 20. 5 and negative 20 makes negative 15. Negative 15 times negative 2 is 30. Negative 6 plus 30 is 24. The last column answer is your remainder. The remainder always needs to be put over the original denominator, which was x plus 2. That's why I have 24 over x plus 2 here. And then because this 1 came from the 4th power, when you're dividing out 1 power, your answer will be 3rd power. So this is a 3rd power term, 1x to the 3rd. 2nd power term, negative 5x squared. 1st power term, 10x. No power term, negative 15. And you can see that answer over here on the side. For question 8, we got another geometry problem. It says the area of the rectangle is 2x squared minus 11x plus 15. So I drew myself a rectangle and put the area inside. The length of the rectangle is 2x minus 5. Put that on the length. And they ask us, what is the width of the rectangle? So we have the width over here. When we're doing a rectangle, you know that the area is length times the width. So I need to solve for the width. So I just divided both sides by L, and I got the width is the area divided by the length, which would be the expressions that they gave me, 2x squared minus 11x plus 15 divided by 2x minus 5. And when we did problems like this in lesson 2, I talked about how you can't have a number other than 1 as your coefficient for the denominator variable. And right now it's 2, so I need to divide everything by 2 down here. But if I'm going to divide the bottom of the fraction by 2, I also have to divide the top of the fraction by 2 for all the terms. So when I did that, I got x squared minus 11 halves x plus 15 halves divided by x minus 5 halves. And then again, I just did synthetic division, same process as in number 7. This time I got a remainder of 0. This was 2nd power. My answer is 1st power, x minus 3. That's the width of the rectangle. If you wanted to check your work for this problem, you could go back and multiply x minus 3 times 2x minus 5 and make sure you ended up with the area formula for the rectangle. For question 9 on the back, we need to state the degree and the leading coefficient of the polynomial in one variable. If it's not a polynomial in one variable, explain why. So the first thing I'm going to look at is there only one variable here? And I see that there's only m's, so I know it's a one variable thing. However, because you are not allowed to have variables in the denominator, this is not a polynomial of one variable. And that's all you have to write for question 9. For question 10, we're finding p of negative 2 and p of 3 for this function. P of x is negative x to the 5th plus 4x to the 3rd. And there's 2 ways you could do this. The first way, which I think a lot of you guys are just going to go for initially, is to plug negative 2 in for the variable in the equations. And if you do that, you're going to get 0 when you plug in negative 2, and you'll get negative 135 if you plug in 3. But the other way to do this, which is technically the way that you're supposed to do it, is essentially that you do long division or synthetic division, whichever is your choice, and you use this as the number that goes in the box. So I didn't write that on here, but that's another way that you could have done problem 10. For question 11, we have to look at the picture and describe the end behavior, determine if there is an odd or even degree function, and state the number of zeros. So looking at this picture, I can see that the end behavior, the left side goes down and the right side goes up. Whether it's odd or even, whenever the directions on the ends are opposite of each other, that means it's an odd function. And the number of zeros, well, let's see. The number of zeros is how many times it crosses the x-axis, which is 1, 2, 3, 4, 5 times. So there are 5 zeros. For question 12, last question here, we says the function c of w equals 0.013 w squared minus w minus 7, and that estimates the wind chill temperature c of w at 0 degrees for wind speeds from 5 to 30 miles per hour. We need to estimate the wind chill temperature at 0 degrees if this wind speed is 20 miles per hour. So I know from the problem c of w is my wind chill temperature, w is my wind speed, and they want me to talk about the wind speed when it's 20 miles per hour. So w is 20 for us. So all we really need to do here is take the number 20 and plug it in the equation. You're going to drop this in your calculator. When you do that, you should get negative 21.8. And so the temperature, the wind chill temperature, is negative 21.8 degrees Fahrenheit. That's what the wind chill would feel like. All right, that's the whole quiz for Unit 2, Lessons 1 through 3.